Hello mathematicians, we'll now have a look at the last of our topic areas within this particular chapter, and it's completing the square. Now completing the square is again a valuable algebraic tool for some things that we'll look at later on, mostly to do with the quadratic formula, but also to do with parabolas and circles, as we'll see. What completing the square is a technique which is based on the expansion of a square, the square of a binomial. So you'll remember, if I have something plus something all squared, it's square of the first, square of the second, and twice their product. So if I have the beginning of a binomial expression here, so I've got x squared plus bx, the way to figure out what goes here, which would be required to give me a perfect square, is to say, well, if I look at this and this, then twice whatever it is which is squared on the end corresponds to that. So in other words, I take half the coefficient of the term to 1 power and I square that, and that will equal the perfect square of x plus a half of that. Now it's a lot harder to say than do. So let's just have a look at a couple of these, basically the trick for completing the square, and then we'll have a little bit more to say about it. So if I had x squared plus 6x plus something, and that equaled some perfect square, what are the missing bits? Well, from this up here I can see that what I do is that I take my 6, I halve it, and that means that this is my perfect square, x plus 3 all squared, and my half, the 6, the 3, is what's squared to go on the end. So the perfect square, x plus 3 all squared, is x squared plus 6x plus 9. Now you won't need to do many of these to get it under control, so I'll just do a smattering of them. So c, for example, half of negative 20 is negative 10. So my perfect square is a plus minus 10, if you like, a minus 10. And when I square 10, that will be 100 in here. This one over here, the numbers are just horrible, that's all. So half of negative 7 on 2 is, half of negative 7 is 7 on 2. And that means that on the end here, I have 7 on 2 squared, which is 7 squared over 2 squared. Okay, so they all operate like that. That won't take you long to master at all. However, it's important to realize that that was just practicing a little trick, if you like, but I can't do this out of context. What do I mean by that? Well, you might just have to really concentrate on the next bit to get the subtle difference. So as I said, this bit is just playing a numbers game. But suppose that what I had was something like this, b squared minus 100b. What I can do is to use the technique of completing the square to just write this in a different way. So, and the reason I would do that is because it gives me another way of solving quadratics. Now, it's not my method of choice for this. If this was a quadratic to factorise, you and I both know that we would just say b outside of b minus 100. If it was a quadratic equation like this to solve, then we would say b outside of b minus 100 equals 0, b equals 0, or b equals 100. But I'm going to just use this example, and maybe I'll leave it as that. Maybe I'll leave it as this is something for us to solve. So, and I'm going to do completing the square even though it's not the most useful technique. What I'm going to do is to say, well, what do I actually have to do to complete the square? So I would have to say b squared minus 100b, and then I'd take half of this, which is negative 50, and I would square it. And when I do that, that will give me 2500. But when I've completed that square, Where have I dragged that 2500 from? Well, out of thin air basically. So I've taken the left hand side and I've added 2500 to it because I wanted to complete the square. And what is the square that I've completed? The square that I've completed is that I've converted the left hand side into that. Now if I've done that, it's by dragging in this 2500. So if I've added 2500 to this side, I have to add 2500 to that side. And so what I get is an entirely different problem, that b minus 50 all squared equals 2500. And I go away and I solve that problem. Now, I'm not going to do that. I just want you to realize that if I do complete the square, and if there is an equal sign there already, I can't just complete it because I want to. I have to compensate for that. Now I'm hoping that will be more evident down here when I use this technique of completing the square to find the solutions of these quadratic equations. So let's take our quadratic equation here, and we're instructed to use completing the square. We have no choice. So what I would do is to say, well, what I've really got is x squared plus 4x, and that 1 there is a bit of a distraction. So I'm just going to shuffle it over to the other side and make it plus 1. And then I'm going to say, well, what do I need to complete the perfect square? So what I need is that I would take half of this and square it. But if I've done that, if I've added a 4 there, I have to add a 4 over here. So what do I now really have? Well, on the left-hand side, what I really have is that perfect square. X plus 2 squared equals 5. And now, I focus on solving this equation. Now I'll just scroll down to give us some space. And when I solve this equation, how would I do that? Well, we know if I want to undo a square, I take square root. So square root of x plus 2 squared is x plus 2, obviously. Square root of 5 is that, it's a third. But you also know it could be plus or minus, which is a key point to this. So therefore, the values of x are, I'll take that 2 across, negative 2 plus or minus root 5. Now, you can probably see, if you think about it, that if I had this problem up here to solve, with what I know already, I would have had two choices. I would have first of all said, well, let's see, are there two numbers that multiply to minus 1 and plus 4, which there aren't. Then I would have gone to my quadratic formula. Now, if I go to the quadratic formula, that gives me x equals minus b plus or minus the square root of b squared, which is 16 minus 4ac, so that's minus 4 times 1 times minus 1, so it ends up being plus 4, all of that over 2, which is then minus 4 plus or minus square root of 20. Square root of 20 is 2 root 5, that's all over 2. Take 2 out as a common factor, so I write it as 2 times minus 2 plus or minus root 5 all over 2. And of course what I get is this here. So completing the square is actually the process on which the quadratic formula is based. Most times we don't bother completing the square unless we're instructed to. We just go to the quadratic formula. But we should be aware that this is where the quadratic formula comes from. And sometimes when we do exercises in later chapters, which are not just focused on solving the quadratic, completing the square is our go-to technique. So I'll just do one other of these to get it sorted, and I'll leave the one in the middle because I haven't got space. So if I have this equation to solve and I want to complete the square, my technique is take that, shuffle the 7 over to the other side because it's a distractor, look at half of this, which is negative 4, and square it, and remember this will always be added. And if I've done an addition of a 16 to that side, I've got to do it to that side. What is this perfect square? It's that. So that equals 23. Now solve this equation. So square root of both sides gives me this. There's nothing I can do to make square root of 23 look nicer. And therefore y equals 4 plus or minus root 23. So that should be what my quadratic formula would have given me as the solutions for this quadratic equation. Okay, so have a look at the exercises here. Remember, there's a set of review exercises, and perhaps even more important than that are HSC questions, past HSC questions, which we will work together through. And then your very first topic test.